Good morning, viewers. I am Professor Nandini, Department of Electrical and Electronics Engineering from Hindustan College of Engineering and Technology, Coimbatore. The topic we are going to see is Junction Field Effect Transistor. So it's called as JFET. So overview of the content is introduction about JFET, advantages of JFET over BJT, and types of JFET, symbol of JFET, standard notations used in JFET, water analogy of JFET, operation of JFET, and applications of JFET. Introduction. Junction Field Effect Transistor. It's a semiconductor device. It is in the family of field effect transistors, right? It is also a field effect transistor is also a type of a transistor. The operation is done by applying electric field across the junction of the device. Normally, JFET is a 3-terminal semiconductor device. It is commonly used as switching devices and as amplifiers. JFET is a voltage control device. Yes, here the potential applied at the gate terminal controls the drain current. So, JFET is a more advantageous voltage controlled device. Advantages of FET over BJT. FET has high input impedances in the range of megaohms. The FET operates in the temperature which is stable. The size of the FET is small when compared with BJT, so it can be applied to many digital devices. The fabrication of the FET is more easy when compared with BJT. BJT is a bipolar device, that is, the conduction takes place by both majority carriers, that is, both majority and minority carriers, that is, holes and electron. FET is a unipolar device. It uses only one type of majority carriers, either electron or hole. Next is when compared with the noise with BJT, FET has less noise. Usually, the FET is being used as an switching devices and also as an amplifier. JFET is a voltage control device, whereas BJT is a current control device. The advantage of voltage control device is that the losses will be very minimum when compared with your current control device. Next. Types of FET. JFET. That is FET, we have two types, JFET and MOSFET. In JFET, we have two types, N-channel JFET and P-channel JFET. In MOSFET, we have two types as depletion mask type and enhancement type. Depletion type also we have two types as N-channel depletion MOSFET and P-channel depletion MOSFET. In enhancement type also we have N-channel enhancement JFET and P-channel enhancement FET. So these are the types of. So JFET is of two types, that is N-channel JFET and P-channel JFET. And the JFET has three terminals, that is gate, drain and source. In this diagram we can see In your N channel JFET and also a P channel JFET, the terminals have been shown. See, this is your drain. This is your drain. Next is your gate terminal. Next one is your source. So the three terminals have been shown in both your N channel and your P channel JFET. So in your N channel JFET, we can see it is an PNP transistor, whereas in your P channel it can be like NPN transistors. Okay. Next is your symbol of your JFET. Here the difference between, this is your symbol. We have shown all the three terminals, gate, drain and source, gate, drain and source in both the N channel and P channel JFET. In your N channel JFET, the difference between the N channel JFET and P channel JFET is your arrow of your gate. It's an arrow of your gate. In your N channel, we can see that arrow is entering into your moving towards, whereas in your P channel we can see the arrow is moving out of your gate. So this is the difference between N channel JFET and P channel JFET. With this we can find whether what type of JFET we are using in our application side. Next is standard notations in your JFET. The channel is nothing but the region between the source and drain. The sandwich between two gates is called as channel, right? The region between your source and drain is said to be your channel. The majority carriers move from source to drain through this channel, right? The movement of your carriers takes place from your source to drain with the help of this channel, right? Next is your source. The terminal through which majority carrier enter the channel is called the source terminal. The terminal through which your majority carriers enters the channel is called source, and it is denoted by the letter S. Next is drain. The terminal through which the majority carriers leave the channel is called as the drain, and it is being noted with the letter D. The drain to source voltage is called as VDS. Next terminal is gate. There are two internally connected heavily doped impurity regions. This region is called as your gate. So we have three terminals, source, drain and gate. With that we also have a channel. These are the four notations we used in our JFET. Next is water analogy of JFET. That is, by controlling your gate, the drain can be controlled, right? Drain voltage can be controlled. So this is a source. Source is like your well or a bow pipes or water tanks. Like the source is a plenty of source, right? From that, by using your gate, it is like a gate wall. By using a gate, we are controlling it so that we can control the drain, right? We can control the flow. That is it. This is the way the application of this is the working of your JFET, right? Next is operation of JFET. Case 1, that is when your gate source voltage, that is a gate and source voltage is applied and drain source voltage is 0. Gate and source is applied and drain source is 0. That time your channels will be very normal and depletion region also will be very normal, right? When your gate source is applied and your drain source voltage is, that is your VDS, is 0, at that time your channels will be very normal, very normal. The depletion regions also will be normal. Next, case 2, when VGS is 0, your two depletion layers and channels are formed normally. That is your case 1. Next is case 2 is when VGS we are going to increase. See to that, this is our gate terminal is from a P junction P, and your source is your N, right, N terminal. So we are going to apply a reverse voltage, that is for a P we are giving with a negative supply, and for our N we are giving with a positive supply. So we are on the whole for a VGS we are applying a negative voltage. So if it is negative, we are going to apply a negative voltage, your depletion region starts to increase and the channel will be decreased. You can see here, you can see here your depletion layer is increased and your channel is decreased, okay. Next is your third case, that is your when if you are going to increase more your VGS, your both the depletion layers will touch each other and there will not be a channel at all. Your channel will be removed, so there will not be any flow of current through the channel. So if you are going to increase your VGS more, the depletion layer will touch each other and channel will totally be removed, and so no current can flow through the channel. Okay. Next, on the whole, next is your when the drain source voltage is applied at constant gate source voltage, that is whatever is there in your case 1, 2, 3, this is being simplified over here. When drain source voltage VD is applied and that is your VGS is applied with a reverse bias, so the depletion layer is wider at the drain end than when compared with the source end. So when once again the VDS is increased, that is beyond your, now the VDS has been increases from 0, so that your depletion layer at drain end is gradually increased and drain current is also increased. When VDS is equal to your pinch of voltage, the channel is closed. That is, if you are going to increase your VGS more negatively and VDS is also been is equal to your pinch of voltage, your channel is totally closed at drain end and it does not allow further increase of drain current. So drain current will become constant. That is the diagram over here. This is your pinch of voltage, BP. That is your pinch of voltage, right? Next is your JFET applications. JFET main application is being used as a switch. Mainly it is a switching device. It can be used as a chopper. We know that chopper is also a switching device. It is used for as an amplifier and is also used as a buffer. It is used in digital circuits such as in computers and LCD and memory circuits. Because of the small size, it is being applied in all these digital circuits such as computers, LCD and memory circuits, right? Thank you.